Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, we don't have a problem. Today what we want to do is we want to learn how to really just do some projectile motion problems. And we're just going to do one problem because it takes a while to do one of these. These take a fair amount of time. So let's say that we have I'm going to sketch something. And by the way, you're going to have a bunch of words. And please, 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 sketch a rudimentary diagram of what's happening. So I don't have like a problem to do. I'm making it up in my head. But what you're going to have, and notice I'm just starting with a diagram. Let's say that we have a cannon, and it's going to shoot out vertically at 10 meters per second. Okay, and the height of the cliff is 100 meters. And the question is, well, let's see, we want to answer a bunch of questions. How far does it travel? What that's called the range. How far does it go to hit the ocean below or the floor below, right? Where's it going to land? You know, what's going to happen is it's going to kind of go like this, right? And we want to know how long it's in the air. There's a number of questions we can ask. But first of all, we've got to define all of our variables. We've got x variables and we've got y variables. So our x, so this x, I've got x initial, and that's going to be 0, right? We're going to set this to be 0. This is our x-axis. We'll say this is 0, and this is x2. We don't know what that is. x2, we don't know that. Okay. V 1, so what's the initial velocity in the x direction? That's 10 meters per second, right? What's V2? We don't know that either. What's the acceleration? Now remember before we talked about this, acceleration in the x direction, this is in projectile motion, it's only in one dimension, that's 0 meters per second. And the time, we don't know that equals. So we have a couple of variables we don't know. Let's talk about the y. What is the y initial, or y1 if you will? y1, so x and y. Now we need to kind of define this. It doesn't really matter how you do this. So I'm going to say, I'm thinking like the x at y-axis. This is y equals to 0, and this is y equal to 100. That make sense? So initially, y1 equals 100, and y2 equals 0. Does that make sense? Now what is the vy in the 1 at the beginning? Now this is tricky here. There is none. There is no vy because it's moving horizontally. So it's equal to 0. That's the trick on this particular question, by the way. And then vy2 is a different number. With that, we don't know that. What's the acceleration? Now it's accelerating downward at 9.8, actually negative 9.8 meters per second squared. And the t, we don't know. So now we can use our kinematic equations and we can solve for something. Now in this case, I think the best solution is let's find how long it's in the air, because how long it's in the air is going to help us solve the rest of the problem. So let's solve for t. Now notice that the best way to solve for t, you really can't solve for the 1, 2, 3 variables. Here 1 and 2 variables. So this is going to solve the problem right here. So let's solve for t. Now which equation am I going to use? Now I'm going to go back, because in my paper I have written out my 3 equations. I know y1 and y2, or delta y. I know acceleration, and I want to solve for time. I think I need to use the first equation, right? Yeah. So I'm going to use y equals y initial plus vyt plus 1/2 gt squared. That's our first equation, and I'm solving for t. So y final, this is initial, y final is 0, so 0 equals 100 plus now vy is 0. So this whole term drops off, right? 0 plus 1/2 times negative 9.8 t squared. So, and this is going to be, so if I'm going to, so this is, or I'll simplify that, I'll say, I can actually just, if you think about it, this is negative, and this becomes negative 4.9 t squared. If I add 4.9 t squared, I'll say 4.9 t squared equals 100. I've brought this over to this side. So I'm going to take my calculator, and I'm going to take 100 divided by 4.9. By the way, when I take 100 divided by 4.9, right, that equals t squared. So that's 20.4 equals t squared. So I need to take the square root, I'm doing that right now, of that, and I get t equal to 4.5 seconds. So it's in the air for 4.5 seconds. So now we know the time on this chart. So this is 4.5 seconds. That makes this, of course, 4.5 seconds. Does that make sense? Now, once we know that, we can answer some of these other questions. How far does it travel? Okay, so what is this final distance? So where is it going to land with respect to the cliff? Well, we know how long it's in the air, and we know its speed, which is 10 meters per second. So to find the distance, or actually this is called the range, how far the projectile will go, I will say, I'm just going to use actually the same equation, by the way, this equation, but in the x, I can say x equals x initial plus v initial xt plus 1/2 at squared. Now remember, what is a in the x direction? It's 0. So this whole term drops out. So x equals x initial, which is 0, it's starting at 0. And it's just going to take vix, which was 10, times the time. And the time was 4.5 seconds. Well, I don't even need a calculator for that one. 10 times 4.5 is 45 meters. So the ball, the projectile, this distance will be 45 meters. That make sense? The last question is probably the hardest, is what is the v2x and the v2y? Or oftentimes, what is the final velocity of them together? Well, the nice thing about the v2x is it's going to be the same. It's not slowing down as it's going here. So this is going to still be 10 meters per second. And you're going to see this in a second, the tricky on this. And this is the harder one. What's the Vy2? Well, again, we can go back to our kinematic equations. Now we can only work in the y's. And I'm going to use, I think I want to use, I'm going to use equation 3. And equation 3, remember that's v2 squared equals v1 squared plus 2ad, right? And so v2 is what I'm solving for. So v2 squared equals v1 squared. v1 squared is 0 squared, that's easy, plus 2 times 9.8 times my height. This technically should be a y, times 100. So 100 times 200 times 9.8 times 2. And it gets me, so I get v2 squared equal to 1960. And of course I can take the square root of that, and I get 44 meters per second squared. So that's my Vy2 right here. So often the questions it's asked is, what is the final speed of the ball when it hits the ground? Now, this is where it's a little tricky. It's actually a trigonometric thing. He's traveling in the x direction at 10 meters per second. He's traveling in the y direction at 44 meters per second. So his actual velocity, because he's hitting at an angle, is the hypotenuse of this triangle, right? And so I then just have to do Pythagorean theorem. So 44 squared plus 10 squared, and I get a big old number, and I take the square root of that, and I get this to be 45.4 meters per second. I might even ask the question at what angle this is. And if I ask that question, then you'll use SOHCAHTOA and arctan or sine or whatever you want to use to find out what this angle is. At what angle is it hitting when it lands? Pretty steep angle, I think. The further the height of the cliff, the steeper that angle. It almost might be completely vertical. It might almost be a 90-degree angle, because you try and find, what is that angle when you're solving the problem, or a 0-degree angle, I think it would be. Anyways, that's how you solve this problem. The next problem is, what if you have an angle at the projectile, because that changes the problem. Houston, we don't have a problem.